Okay, this is a hopefully a quick tutorial on how to design and calculate a normal 13D house using GBIM software. Typically I think most of us like to start just by laying out heads, feel like we're getting something done, so we go there first. So what we'll do is we open up the sprinkler matrix. It's built into GBIM, and we can change these sprinklers. Typically you can do it by using a SIN number. But at this juncture, I've already got this one built in, a SIN sprinkler. So what I want to do is click on it to make that our current sprinkler. This is the head that we're going to use. And so then we just save and close to get out of that. Then what we can do is come up here. This is a GS3, which is the same head that we just determined that we're going to use. And if we click on this, we can lay out a head. Then you can, use a space bar or something to repeat the command, or an enter or something like that. Personally, I kind of like to just copy them using the AutoCAD copy selection, and then I don't have to keep hitting the repeat command type thing. I'm just going to lay out heads. I'm not going to spend too much time on determining exactly where they need to be. You're going to lay down some sprinklers. So in doing so, this is typical pretty much for anybody or any kind of form of software or whatever. But anyway, this is probably not good, but we're going to call it good. So this is our sprinkler layout. And then typically what I like to do is also there's stairs. There's another story to this house, but we're not going to deal with that at the moment. That's for another tutorial. But at any rate, what we'll do here now is what I like to do is typically houses are going to have ceiling heights of 8, 9, or 10 feet. So what I'll usually do is I'll just pick all my blocks. This is just typical AutoCAD stuff here. And I'll go over here and I give a position Z of 10 feet. So now my heads are elevated to 10 feet. So if we take a look at this and then say an ISO view, you can see that the heads are elevated above the house. So there we go. Now, now that we're got fire sprinklers, it's probably time to maybe pipe them. So I drew a little circle here just to give an idea where the source was going to be. So this is going to be our water source. So the command is GBIM place source. And you can see how it kind of finishes it out for you. So that's the command that we're going to do. So we now have a source. So what we'll do is I'll put it in the center of that mark. And now we put in our pressures. So let's say this typical house, we got 55 pounds. We can do a flat curve, but in this case, let's go ahead and do and then we'll say it 50 GPM, and we won't take any hose stream at the source. So there we go. So this can be elevated. Right now it's at a -2 height. There's different ways of doing this. The temperature or the pressure reading was probably taken at about 2 feet above, so you can get a couple of pounds that way. Oftentimes I will elevate this to maybe 2 feet above, and then so now we can pipe in our underground. Well, there's going to be a meter, so on and so forth. So this is when we're running pipe. So running pipe, what we can do here is we can look at our pipe, our default pipes, or our pipe properties, however you want to look at it. This is a file that I made. This is basically a typical house. So our arm over and drop and branch lines are all CPVC pipe. We can run various different forms of underground, but typically I just use a CPVC for underground. I might use what I call a grid line in order to do that. So that would be a GP, which is GBIM pipe GP4, number 4. That would be the command to pipe that. There's other ways to pipe it as well. It is a grid line. We have commands for running grid lines. I'll show you how to do that. But for right now, I think that I would use that as my underground piping. So what we can do is, in this I'll typically draw in an ISO view so I can kind of see what I'm doing here. So what I'd like to do is I can it was GP4 was our pipe, so that's one way of drawing it. GP4. That'll draw pipe. Another way of drawing that pipe is to go over here to 1¼ pipe and go up here, and that gives you a G, which is a grid line, 125, which is 1¼ grid line, same thing. So that'll end up being the same pipe. So if we click on this, and we come over here and draw, that's our pipe going down. So now, if I put my ortho on, I can kind of head in a certain direction. So what I'm going to do is, once again, we're not going to get super precise where everything is, but I am going to draw a little bit underground there, and now I can go back up to my plan view, and we can see this is our pipe going along here. So we are going to need a meter of some sort, and that's usually going to be something underground. So we'll leave this at 2 feet. Like I say, the elevations can kind of vary. Devices in GBIM are also pipe, usually. So it's drawn as pipe. So if we go back in here and look at our pipe matrix, you can see that we have a flow switch in here, and we have some various other stuff. And there is a 1-inch water meter in here. It has a built-in curve to use for these meters. So this pipe, so to speak, device is GP1. So one is, if I click on it, that makes this our default pipe. So if I just type GP, that'll give me a GP1. So I can grab this guy and I can draw it as long as I want to, say 12 inches. Okay, so that's 12 inches. That is a water meter. Now we can go back to maybe our normal 1¼ underground that we were thinking about running, which we're using as grid, we call a grid line. And so I'm going to grab this and go on up somewhere, wherever this is going to enter the house. I'm not exactly sure where that's going to be, but we'll do this, and then we'll do this, and we'll get over here, say, close to this house near the corner somewhere. So now we've got essentially our underground drawn. It'll look something like this. Once again, that is a meter, so it looks a little different. And so we go back to our top view. Now what we can do is we can have some form of a riser. So the riser may or not be inside, outside, whatever. Once again, I don't want to get too deep into all this design. This is more where you have to know where everything is and so forth. But what we can draw is, let's look at our matrix and see if we even have a riser in here. Doesn't look like that we do. If you want to add one in, we could. Really not at this point. Really all we need is pipe. So we're going to just go ahead and continue to use our, we'll use a 1¼ branch line. Now we'll use an 1¼ grid line for pipe, for our riser. So what we can do is once again draw our 1¼ grid line, grab this guy, and we'll come up to, usually what I do is I just come up somewhere and stop, and then I can look at where I ended for an elevation, and I figure I want to be approximately, let's say 2 feet above ground. So now we're 2 feet above ground. We started out below ground, right? And then now we're going to have this particular case. Let's say we're going to have a, let's see, I think it's we have various different GBIM place commands, and that's usually placing some kind of valve or sprinkler or something like that. Place sprinkler. So there's some of these. This is, I believe, a threaded check valve. So we'll probably need some kind of check valve in this thing. So if we choose this item, it'll put one at the end of it. So there's our check valve, because we're probably going to have that in there. So we might draw a little bit more pipe up to into here. And once again, that's let's put this one 3 feet above, and then let's put a flow switch on this guy. So what we can do is go up here and look at our pipe matrix, figure out where our flow switch is. It's GP5. So we say GP5, and we can draw a little flow switch in. Let's just go 6 inches. We'll call that good. And then back to our riser pipe, our normal riser pipe, which right now we're using this pipe. And we'll take this all the way up to, and once again, I just kind of terminate it, and then I go over here and take its NZ, and I'm going to make that 11 feet. That's basically a foot higher than the sprinklers. So that's what we're going to do for the moment. All right, now we'll use branch line 1/4 pipe, which is going to be this red one. We'll use that to get into the house. So I'm just going to kind of pop it in like that, and then we can go look at our top view. So we're gonna call this, this is how we enter the house. Now we may do that down low or maybe do it up high. Once again, it doesn't really matter much. Once again, I just kind of want to show how we can do this and do it fairly quickly. So now we're into the house. And so I think we'd all agree that most houses are on some kind of a loop. Once again, we probably can't draw it exactly like this, but this is what I'm going to do. Now I'm going to switch to 1 inch because typically our looped pipe is going to be 1 inch on a house. So we're going to go here and draw some 1 inch branch line. I think that'll come over here, and we might just do something like this and then come across here. We'll go ahead and just kind of zoom by all these heads. We'll get over here, kind of split the difference between these heads and come across and something along these lines. Come on down. I'm going to do a perpendicular to this pipe. And then I'm going to close it. And there's a possible form of a loop maybe that we might have. Now I'm going to go back here and draw some more 1 inch. What I might do here, once again for the sake of argument, we're just kind of sticking this in here. I'm going to use the midpoint of that and then come over here perpendicular to this. Okay, now this is very important in GBIM. This pipe is not broken to that pipe. Now there's many ways we can do that, but for right now I'm just going to show the quick, down and dirty, simple way. I'm going to take this guy and just trim it back to here. And I'm going to take this one and do the same. And the reason we have to do this is that water needs to flow through this pipe. And so now I'll get some more of this 1 inch pipe and I'll reconnect these at the junction points. And make sure we snap perfectly to our pipes. We don't want to snap to anything else. And okay, so now just to make sure, I'm going to grab these lines. Actually, I'm going to grab everything, but I'm going to look at the lines that I just drew and make sure that they're all at 11 feet. So they all start and end at 11 feet. So they are elevated higher than the sprinklers. I'm also seeing something through here. We might need some pipe through here too. I mean, this is, could be, so. All right, well, for the sake of argument, let's go ahead and make this like a compound type of loop here. So I'm going to go here. I'm going to just use the mids. This is not something we would normally do, but I'm going to do it now just to get something drawn here. So we're going to do this. Now the same thing, these have to be broken. There's other ways to break it. There is an automatic riser nipple command. Since these are touching each other, they actually won't draw a riser nipple, but we can make it break that way. So we can say GBIM auto, and then see all these riser nipple, auto RN 125. It really doesn't matter because it won't draw. And so you select one pipe, and then you select another pipe. And then normally it would draw in a riser nipple here, but since they were touching each other, it didn't draw in anything, but it did break it there. So you can see it's broken. This is another way of doing this. So we would need to do this here as well. So once again, you can use this cheat and use this riser nipple command that we don't even have a riser nipple, but it will break the pipe at those points. So you can see by the highlights that they are broken there. So we got one more to do. So I'll do that here. And when it says first pipe and second pipe, it really doesn't matter which one you go first. It just breaks them there. So now they're all broken, which they absolutely need to be. So now we've got a weird compound loop of pipe, but they are there. So now that we have all this here, we can run this a more automated command here because we got our heads where we like them to be. We got our pipe our main loop of pipe where we want it to be. So then we can go to this command, and this one, there's two commands. This one's an automatic drop and arm over. So if we click on this guy, this one is more kind of a one at a time type of thing, but we need to pick a line first, and then you pick a sprinkler or multiple sprinklers, and it connects it. It breaks this here. It put in an arm over and a drop. And if you want to see that, it looks like this. So now you have an arm over and a drop. So that's kind of a quick, slower way to do this. Sometimes there's be some issues like with this. This one is not directly lined up. So what you can do here, I would look at this first and maybe extend this out a little bit more so it has a piece of pipe to connect to. The rest of these look like they may connect okay. So now there's another command similar to this one, but it's more of a, you just choose sprinklers on this one, you don't choose pipe. And each head will seek out the nearest pipe to connect to with arm over and drop. So as you can see, looks like it got maybe all of them. See, some of them, if the distance is too far, it will not do it. So that one didn't do it. And then some of these other ones, these get a little funky because it's so close that it did not draw an arm over. This is important to know, because this one didn't draw an arm over because the arm over would have been too short. So it is kind of important to go in there to fix this. Now we know this is plastic pipe. It doesn't necessarily have to be dead on perfectly. So this would be one way of connecting that. Some people are a little more anal than that, and they don't necessarily like to do that. Usually what I would do is grab both of these items and move it. So it might slightly moves that head an inch or so, but it does reconnect this to the piece of pipe that it needs to be connected to. This one did draw an arm over. Sometimes that can be an issue if they're too short. This one happens to be through a little under 4 inches. This one might be a little problematic for calcs, but we'll see. We'll go ahead and run it and to see what happens. This guy did not get connected at all. So the way to get that one connected is to come over here and do this more, figure out which one you want it to go to, and then do this a little bit more manual routine here. So you choose which line you want it to connect to. So let's go to this center one here, just for fun, and then select this sprinkler, and bam. Okay, so now it looks to me, now we got another orphaned head over here. So we need to do the same thing over here. We don't want to go through all this stuff. Let's go this way for piping. So we can select this line, and then select a sprinkler. So we're more forcing that to connect. Once again, that automatic connection routine, this one here, the command is gbim-asc. That's automatic sprinkler connection. It will not stretch too far, because the way that, the logic, the way that works is that this head starts searching for a piece of pipe, and it stretches out a little farther, a little farther, a little farther. And after it gets to be about 6 feet or so, it just stops looking. It decides it's not close enough to anything. So these look like they might all be connected. So let's take an ISO look. And then sometimes you can, now that we've kind of got just piping, sometimes it's a little easier to work with if you take your background, your XREF, that's your background, and unload it so we don't have to look at it. And then we can just see pipe and heads, what we're using here. So there it is, pipe and heads. So I'll go back to a top view and take a look. And so we like it. Okay, so now if we turn our XREF, our background back on, so we can kind of see what we're working with. So if we think we want to calculate this thing, what we can do is figure out which two heads we're going to calculate. And so what I think we'll do is do these two heads, even though I don't want to get too detailed on which ones it should be. I'm just going to use these. So what we do is draw a polyline around, and if you use the coverage, you can get some kind of cool statistics to use. So if you actually snap to what your spacing is going to be or whatever, I'm not going to get too accurate with this, but I want to give a good idea. And this can be any form of polyline, you guys. It can be anything. So I'm going to just surround my sprinklers with the two rooms that it's actually covering. and I'll just, and make sure that you close it. CLO, close. This has to be a closed polyline. I usually like to have it, I have a layer in GBIM called construction, which will not print. It will not show up in any prints or anything like that. It's just a good, I usually use it as my my default, my current layer all the time. So when I draw stuff, you can draw all kinds of things. I can draw a line and then use the midpoint of that line to put it in, in a room or whatever. I use it for construction stuff. This can be on that layer. Later on, when I actually am going to use it and utilize which one I'm doing, I might often change it and put it on a layer of your node labels, which is yellow. And so that's the node labels. But you'll need this in order to calculate this fire sprinkler. Now, we have to know what pressure is required for these heads by their, what that might be. So, and you already know how to do that. I'm not going to do that. I'm just going to show how to calculate this thing. So now that once we've got this completely laid out and all the head, everything is connected, everything has a path now back to this source. So we should be able to do what's called a calc prep, or it's a CP, GBIM CP, which stands for calc prep. We have to prepare. I'm also going to get rid of this background again, so it's not in our way. So now I want to prepare these pipes and sprinklers to be calculated, and that's with a calc prep program. So that's up here. GBIM CP is the name of the routine. You can click this button if you want to. It looks for this source down here, and then it connects pipe, and you can see the flow arrows that show which way it went. It's not necessarily a hydraulic flow. It's just a flow going away from this source. It starts here and works its way this way. See how the arrow goes this way, this way. They do come together at some point somewhere. They will come back together. Looks like this one's heading this way and this one's heading this way. So these rejoin back together right there. And that's probably happened somewhere else at some of these loops. But since the pipe turned this dark blue color, it looks to be probably prepped properly. Doesn't necessarily mean it is, but it's a good sign. So this thing looks like it might be ready to calculate. So one other thing we might want to do, because sometimes you want a constant point. With the house, we all know we need a 5, where it joins, we needed to take a 5-gallon. So what we can do here is another one of those place commands. I'm going to say a place hose. So if I place a hose, and I'm going to say I'll put it down at the very bottom of the riser. It's going to look like a play pipe, but we only want 5 GPM coming out of that guy, so we'll put it right there. And then also sometimes you want to base a riser just for a reference point. So if you can place a riser, and we can put that anywhere we want, it really truly is just nothing but a riser symbol. And so it looks like this from the top, but calculation wise, it'll use that as a common reference point. So now we can calculate this guy. So we're going to calc those 2 heads. I honestly don't know what pressure they're going to need. I don't want to sit here and look this up on Senju's site at the moment. So we're just going to go with our normal run-of-the-mill 7 pounds. And so what we'll do is, now that we've prepped it, we'll run a calc, GBIM calc, or it's actually calc it is the command. And now it's asked if you want to run that calc prep again. It never hurts, so why not? Let's do it again. So this way it can see where the other things that we've added. This will come up. Hayes and Williams, Darcy Weisbach, what our safety percentage we want to be. We can make that 0 if we like, or any number we want that to be. It will recolor pipes by velocity. Right now, we just leave it at that. And the rest of this stuff, pipe lengths, none of that stuff really matters at this point. So we say, okay. So now it's going to come up and ask us which heads we're going to flow. We've already checked this one. This has to be checked. It's not just pick it. It has to be checked. So that box has to be checked for the sprinkler heads that you want to actually flow water through. We say, okay, now it says select a remote area. This is our remote area that we picked. It has to be a polyline, and it has to encompass the sprinklers that we want to calc. So our minimum pressure, we're just going to go with 7. And so that calculates to be a GPM of 13 gallons for each one of these. We can plug in 13 if we like for both of those heads. And then the remote sprinkler node, we don't know which one it is. We don't really care at this point. It's going to do it for us. So we're going to say, okay. And now it's going to calculate. Off screen, it had a it showed a status line, but you didn't see that here. But so then this comes up. So this is your lines. This is your 10% safety factor is the green one. The blue one is the water supply that we put in at the source. This purple is our base of riser flow and pressure. And then this is our demand at source, which would be right there. So we're well under. This one calculates nicely. If you want to look at the calcs, this is what they look like here. When you're troubleshooting, trying to figure out where problems are, you can sort these by looking at velocity. So our biggest velocity was this piece of pipe, which is noted by the AutoCAD handle. So we can find this later if we actually need to find that piece of pipe. The pipes are named by the AutoCAD handle. So if you want to do it by friction loss, you can see which one has the most friction loss. It's also the same one with the highest velocity, or which one's flowing the most. So we can see which one has the most flow. That's actually ascending. We go to descending. This one has the most water flowing through it. It's going to be some of our underground pipe. So there it is. It's calculated. Here's a cover sheet. This is editable. And save these curves. It's really not for the calcs. This is showing the curves that we used. A flow switch curve is 3 pounds no matter what you do with it. So we lost 3 pounds at that flow switch. So if we go back over here and look at these devices, you can see there's a couple of items here that are devices, right? So this one's a flow switch, and it's got a little more, but it's 3 pounds, which is normal. And then your water meter came to 4.056, and that was calculated by its curve while flowing 31.2. So if we go look at these curves, and we go look at these water meters, a 1-inch water meter, flowing 18 is 2, flowing 23 is 3, flowing 31 is 4. It was somewhere between 31 and 26. So we got that 4 point whatever something. Actually, it was over 31. So so it's extrapolated that number or interpolated that number to get that friction loss. And then there was our graph. And then go to calculations. If we want to see what the report's going to look like, we can do this, and it'll give us a preview, which landed on the other screen. So I'll bring it over here so you can see it. So this is what the report looks like. That's our nodes. That's our graph. There's our pipes, and that's, you can make a PDF of that or do whatever that you want with that. So there you go. That is a designed and calculated house. Now these lines that we drew will not plot. So what we need to do is do some finish on this now. So if we say GBIM finish, it places thicker polylines around the pipe that you want to have thicker polylines around. So we can do that. This still won't print or show up, but this will now. And then if you want the cuts on that, there's 2 ways to cut this. If you do a GBIM cut it like this, and then you can determine, you know, how long a pipe needs to have cuts on it. So we can say a 4-inch pipe will show cuts, and then whichever ones you cut will label, and they'll also label with the length like this. Right now this is center to center because we did not do a list prep on this thing. So this is center to center. So another way of doing that is I call it an R cut it, which is like a residential style cut it. R cut it, GBIM R cut it. So if you do that, it just gives you the sizes and not necessarily the lengths of the pipe. So these arm overs are 3/4, and the loop is 1 inch, and our incoming was 1.25 inches right here. So you can see how that worked. That's another way of labeling the pipe. And one other thing you can do is called a list prep. So we can list it for listings. And this one always asks you if you want to save the drawing. It's always a good idea to do that because some of these routines are kind of goofy. And then you can restore the colors or not, doesn't matter. And then, so if we look at it now, we can probably see that the pipe it's actually a 3D pipe going over all these things. And then we've got fittings and whatnot. There's even 3D sprinklers. So typically you don't want to print this. We use this for more like BIM stuff. You probably don't need it here, but it is a good idea to run it one time. You can also do an un-LP, which removes the the data is still attached to the pipe. And so now that by doing an unLP, it actually made all that 3D stuff disappear. But we can still see what's going on. So if you want a recap of your material, you can say GBIM and then BOFM, which stands for Bill of Materials. I know it's a weird command, but that's what it is. And if you do that, you can get a summary of the fittings and pipe and head count and all that kind of stuff that you need for the job. And that you can put to Excel or various different other things. But there it is. And all the rest of this stuff is normal AutoCAD stuff if you want to use paper space or do whatever. But you have to do that finish because those pipes will not print unless you put this polyline finish over the top of all this stuff. So there you have it. It laid out and calculated 13D house in 30 minutes.